Let's continue doing our review for the Unit 3 exam. And so I'm going to be listing up here at the top the things that you should now know. So you should be able to measure the distance to a star using the parallax idea. You should be able to measure the luminosity of a star by using the photometry equation. And now we want to talk about how do you measure the mass of a star. So we need to do, the only way that this is going to work is with a binary star system. So you're going to have two stars that are in orbit around each other. And you can measure with a stopwatch the period. So the period is going to be the amount of time that it's going to take to orbit. So you could measure that with a stopwatch. Then we're going to take that and put it into Kepler's laws. So the R that's in that formula is going to be the distance between the two stars. And you can do that by using some geometry. If we know the distance to the two stars, we know this distance, and we can measure the angle between the two stars, we can figure out the distance between the two stars using trigonometry and geometry. You're not going to do that. But we could measure the distance to the two stars from up here by using the parallax formula. So just know that it's possible to measure the distance between the two stars. And if we know how long it takes them to orbit each other, we can plug it into that formula, and then we find the total mass of the two stars. So it would be the mass of this star plus the mass of this star. That's what we could calculate, which still isn't enough, because we'd want to know what is the mass of this one, and then what's the mass of this one. So we need to do one more thing, and we need to use the concept of center of mass. You're not going to need to know any of the formulas to calculate the center of mass, but you should know what center of mass is. So like, for example, if you've got a teeter-totter, you could have a very large person over here balanced by a very small person over here if the pivot point is right there. So this pivot point represents the center of mass for this system. So just know, what do I mean by center of mass? So by combining center of mass and Kepler's laws, we can figure out the mass of a star. And so here is a sample calculation for you, which you don't need to worry about for the exam. I'm just including one so that you can see that it can be done. Okay, then what astronomers have done is they have measured the brightness, the luminosity of thousands of stars by using the idea of photometry. They have measured the masses of those stars when they were binaries. So when you have two stars in orbit around each other, those are binary stars. They have calculated their masses. So they know their luminosities, they know their masses, and then they plotted it on a piece of paper. So in that chart there, luminosity goes up and down, the brightness, and then the mass goes this way. So by plotting this, that means that if you know the luminosity of an unknown star, you can find that luminosity on the up and down part and then bounce it off the curve, and then you can figure out what the mass of that unknown star is. So that's the whole purpose of it. So I could give you a chart like that on the exam and then tell you the brightness, tell you the L, and then ask you to tell me what would be the mass of that star. And then you would just bounce it off the curve and tell me what the number is. Okay, let's do temperature. So let's include T for temperature. That's another property of a star that can be measured. Now, in order to do this, we need to know what a black body is. So that you have this curve, so that's the black body curve, and then you'll notice that there's always some place on the curve where it is at its maximum. So that's lambda maximum, the maximum wavelength for that particular temperature. And so there's Wien's law, which says that the wavelength of a black body, the maximum wavelength, is related to its temperature. So back in unit number 1, you did problems in which I told you the wavelength and then you calculated the temperature. Well, you did that back in unit 1, so I'm not going to have you do it again. But you should know how to do it, and you should know how Wien's law works. So know what the purpose of Wien's law is, know what a black body is. So an astronomer is going to put a diffraction grating on their telescope. So the diffraction grating was that piece of plastic that had the lines in it, like this. And then they take that thing, they put it on their telescope so that the light from the star is spread out into the rainbow of colors. And then they're going to look for which wavelength is the brightest in the spectrum. And then from that wavelength, they plug it into that formula, and then they can calculate the temperature of that star. So here's a sample one where I calculate the temperature of the star. You're not going to do that on the exam. Okay, and then this one is another way of doing it by noticing which colors are highlighted in the spectrum. And so that means that there are certain elements in that star that are excited at that particular temperature. And so what we did was that there were certain letters that went with each of those types of stars. But you're not going to do it. So on the exam, don't even worry about this one. All right, let's take a break. When we come back, we will talk about how to calculate the radius of a star.